The focus of this tutorial is to perform calculations using equations associated with the specific heat capacity of matter. Now recall that each substance has a unique value at which it can gain or lose heat in terms of energy, which causes a change of temperature. Now I have the formula written up. Cp is equal to Q divided by M delta T, or it can also be written as Q is equal to Cp M delta T. Now here is really quick what they mean. Cp is the specific heat capacity, that's that unique number. Q is the energy transformed as heat, whether it's heat gained, that'll give you a positive number, or heat loss, that'll give you a negative number. The M is the mass of the substance, and again, change or delta T is the temperature change, and we can calculate that by looking at delta T is equal to temperature final minus the temperature initial. So I'm going to leave this up here on the side so you can go back and refer to it as we do different examples. The first example we're going to look at is we're going to try to calculate the amount or the specific heat capacity of copper. It takes 487.5 joules to heat 25 grams of copper from 25 degrees Celsius to 75 degrees Celsius. And the question is, what is the specific heat capacity of copper? And we want to calculate this in terms of joules per grams degrees Celsius. So now let's look at the numbers we have given to us, and we can go from there and calculate. So if we have the amount of heat, or Q, is equal to 487.5 joules. And to heat up a substance from 25 degrees to 75, so right there we go to the change in temperature. It starts at 25 and it goes up to 75, so we have final temperature is 75, initial temperature is 25, and it's telling us that the amount of matter we have is 25 grams. So what I'm trying to calculate is that Cp value of copper. And we can always go back and verify our numbers since this is a well-known number. So I'm going to look at the formula in terms of Cp is equal to Q divided by M times delta T. So now I'm just going to replace my numbers in where they belong. So we're looking for Cp that we don't know. We know that the Q value is 487.5 joules divided by my mass amount, which is 25 grams. And it's being multiplied by the change in temperature. Well, the change in temperature is 75 degrees Celsius minus 25, which gives us 50 degrees Celsius. So that's the number I'm going to put here, 50 degrees Celsius, because that's my change in temperature. So from here on out, it's just a simple mathematical issue. Cp is equal to 4,870.5 divided by the value that I get from this equation here, 25 times 50, which gives me a total of 1,250 grams degrees Celsius. And I'm just going to finish off my calculation. If I enter this into my calculator, I end up with a Cp value of 0.39 joules, because that's joules, divided by grams degrees Celsius. So here we could calculate the Cp value of an unknown substance. Here I knew it was copper already, but we could have had an unknown substance if I knew the rest. And going back and looking at the chart, we can determine what kind of substance this could have been. So now let's try a little bit more complicated problem. We're going to look at a problem where we're going to try to calculate the amount of heat in the system. So let me erase my values here. And what I'm doing for that to happen. Get a little piece of tape there. So now my second example, it's still dealing with the heat capacity of matter, is now going to take, if I have 3 kilograms of water that is being cooled from 80 degrees Celsius to 10 degrees Celsius, I want to calculate how much heat energy is removed. In other words, it's losing, quote unquote, losing heat. So my CP of water is a known value of 4,186 joules per kilogram degrees Celsius. These variables are measured in a different unit instead of in grams. Now we have kilograms, but the process is still the same. So let's go through this. I want to calculate how much heat. So I'm going to look at the formula in terms of this one right here. It's rewritten because I'm calculating heat here. So I'm going to be calculating Q, and we're going to multiply that by CP times mass times the change in temperature. And because this marker is dry now, let's go back to the purple. We have the known value of CP of water is 4,186 joules per kg degrees Celsius. I also have a known variable of mass. I have 3.0 kilograms of substance. And the temperature change that is occurring is from 80 to 10. So initial is 80, and my final temperature is 10. So guess what I'm going to get? A negative value because my final is smaller than my initial. So my temperature change is negative 70 degrees Celsius. So now that I have all the variables, let's go back and replace our numbers. So Q is equal to CP, and we're talking about water, 4,186 joules per kilogram degrees Celsius, multiplied by the mass amount, which was 3 kilograms. And that is multiplied by my temperature change that I calculate over here as being negative 70. So from here it becomes just, let's punch this into the calculator. Make sure that you remember that we do have a negative value in this so that you don't get a wrong number. So my number at the end comes out to negative 879,060 joules. That is how much heat was released, because it's a negative number, it's lost, or not quote unquote lost, removed in this amount of water. Yes, it's a large number, but if we look at the CP value of water that we used was 4,186, so that's a big number to begin with. And what happened to our units? Well, over here we were dividing by kilograms, and here I was multiplying. My kilograms cancel out, and my Celsius as well. I was dividing over here by Celsius, but over here I multiplied, so that comes out. Nonetheless, we know that energy is measured in joules.